Yeah, so this talk, okay, watching like Barry's talk, and he had like this cheat sheet and everything. Unfortunately, you're not going to get this from this talk, but rather I'm going to turn it around. I'm presenting you, what is going on in like the protocol layer and what kind of changes we're talking about. And I want you guys to pick it apart and tell us why it is bad. And unfortunately, of course, I said like, what is next in EVM? And when I started looking at all these different proposals for the EVM, it has been, 20-ish proposals, so they're not going to make it into the chain anytime soon. But because of that, and your limited time of 20 minutes, I had to pick and choose. So it's only going to be, some of them. So it's not everything what is on the plate for EVM. Just briefly about Epsilon, this is the team working at the EF researching EVM proposals, both external proposals and stuff we propose. There's the website, epsilon.xyz. You can find every single link, including this slides there, so you don't need to bother with anything else. Now moving on. It was funny, actually, this weekend was the first time I found this design goals with EVM, even though I've been looking at EVM for quite a bit of time. So this is the version from 2015, written by Vitalik. And it's quite interesting because actually all these design goals are kind of accomplished today. I want to highlight the first one, simplicity. That is the one which it accomplished the most, and maybe too much simplicity at this point. So if I would have been there, I would have added like these 2 more points to the design goals. The first one, extensibility. I would want it to have something extensible so that it is easy to add features, easy to remove features without breaking like everything, which is the case today. And also I would have asked to have some kind of once-off validation of code before it gets into the state, so that we don't have all this like weirdness in the accounts as we do today. And I want to motivate like 4 different issues we are kind of annoyed with. And so the first one is what I mentioned, basically, that everything exists in the state. Every single byte is accepted. All these instructions which do not exist yet, they are in the state. So whenever an instruction is introduced, it may do something. And existing contracts may start doing something else, what the authors never intended them to do. So this is like, one of the biggest issues we're facing. Every single instruction introduction is preceded by a lot of analysis. The second one is that, kind of similar, that we also have like the special instruction of push, which is the only one which has immediate data. And it is a special case because we do not want to jump into this push data. We want a really safe control flow. And because of this, we have this special like Jumpdest instruction to detect the places we can jump into. But the Jumpdest instruction is just a single byte, so it can definitely occur in like this push data. So how do we actually solve this problem? We cannot do this at runtime. So we have this complete analysis before executing every single EVM code, and we call this Jumpdest analysis. So there's the byte I mentioned, it's a 5B. It is annoying. The main problem with this process, that we do it every single time, it is expensive, and it's also linearly scaling with how big the code is. And in many cases, we're actually not executing all that code, but we do have to scan everything. The next big issue is like data sections. So if you look at contracts, one basic example is like init code. When you deploy a contract, you have this init code, and that contains the runtime which is going to be in the state. And this runtime is kind of like a data. We are not trying to execute it during init code, we are just storing it. But yet the EVM doesn't know the difference, so we have to handle it as code. The other one, which is actually in pretty much every single contract, is this metadata field added by Solidity. Now, you guys who are using Viper, you don't have this, but everybody else has this metadata. The problem is really it's just too much to analyze, and the more important one is this data section can have Jumpdest, so can we jump there? We shouldn't. And the last big issue we kind of hate in the team is it's not possible to remove instructions because there's no validation at all. And now, of course, I'm presenting a solution to this. It's called the EVM object format. It has these three goals. We are trying to separate code and data. We want to validate all of this, and we want this to be extensible. There's actually a set of different EIPs. And the first two are accepted for Shanghai. Now, what does this accepted for Shanghai means, first of all? It just means that the Shanghai hard fork, which is after the merge, whenever the merge is, right? So it's after the merge, and accepted means that now the core devs should consider, looking at this. It doesn't mean it's going to go in, but at least they are encouraged to look at it. And we also want to get like this other one, the static jumps. It may make into it, but it's not accepted yet for consideration. And the last one, that's pretty far ahead, but I'm going to explain all of these. So this EVM object format actually changes EVM bytecode quite a bit, because right now, as you all know, it's just a string of instructions. And after this, we're going to actually have a header. We're going to have a header with like a magic, a version number, a list of sections, etc., and then the section data. Just to visualize this, so we have the legacy code on the top and the UF code below. You can notice that there's like an extra, 11 bytes. So that's the overhead we have with this. And this is what they actually do. So the magic is the first 2 bytes, the version number. A section usually is like 3 bytes. You have the section kind, the size, and the size is 2 bytes. So there's a code section. We also have a data section at the very end. And this terminator signals that we reached the end of the headers. The code, this one is just a usual init code. It just returns the runtime code, which is the one at the end. Now we're changing a few semantical things here. We're changing how control flow works. So the offsets for the jump and the PC, those are relative to only this section, this code section. They're not, you cannot jump outside. You cannot do any kind of control flow outside of this code section. But we are not changing the code copying because we still want to be able to copy the entire, access everything here. So this is the only semantical change to the EVM. But we also have this validation process, which happens at deploy time. So when you deploy a contract, whether it's through the create transaction or through these opcodes, it's going to go through a validation process. And both the init code, like this entire thing, and the runtime code, this last bit, both of them have to pass validation. And if any of them fail, then the contract creation fails. And actually, we had like a protocol workshop the first 2 days of this week, where this was presented and was like a good opportunity to get like more of the protocol devs to give feedback. And initially, we had like these 4 cases which could happen. You could have this EOF contracts create EOF contracts, you could create legacy contracts, etc. But we decided that EOF contracts creating legacy is not a good idea. So we only have these 3 cases now. And then we have this magic one, right? The main question is, okay, why do we have the magic? And if we have this deploy time validation, what happens with code which is already in the state? We want to make sure whatever is in the state is valid in this UF format. So we deployed in the London upgrade, we have deployed this other EIP which rejects contracts starting with 0 EF. And this enabled us to select this magic, which means that there's no single contract anywhere in mainnet, nor any of the side chains or EVM compatible chains which start with an EF00 byte. So now if you deploy, after this is enabled, now if you deploy a contract with EF00 byte, it has to be valid EOF. We also have like this validation EIP. This is like the second one I mentioned. And what we are validating is that there's no opcode which is not a valid opcode. It has to be a defined opcode. It cannot be a truncated bytecode. And we're also planning to maybe reject like contracts with call code, self-destruct, etc. Now, the interesting one is the relative jumps. Everything in the EVM right now is dynamic jumps, which makes analysis quite hard. And we're trying to turn this into static jumps. And I'm going to give you like a few examples here. So this is what jumps look like today. You have the Jumpdest, which is an instruction itself, takes a byte. Then you push the location, and then you jump. And all this costs like 1,000 gas. Like every such occurrence is 1,000 gas at deploy time and 9 gas to run. Now, with the static jumps, you don't need a Jumpdest because you have that encoded in the relative jump as an immediate data. It costs much less to store, much less to execute. But you cannot use this to actually do all kinds of jumps needed in the EVM. So there are like two major jumps we are doing in Solidity. We are doing these static jumps already to every single location. Just, we are mimicking static jumps with dynamic jumps. So most of the jumps are static, but then the only case where we return from a function call that is dynamic, that cannot be done with a static system. So therefore, we have this other proposal to actually break up EVM code into code sections. So each of the different functions would be different code sections, and you can call into them and return from them. So there's like a call stack next to it. The really interesting part of this proposal, though, is that it also validates the expected stack height when joining a function, and the expected stack height when leaving it. So it also validates the stack, and the functions cannot actually manipulate the stack outside. So it's like pretty cool. How do we are on time? Oh, that's plenty. Yeah, so I mean, these are it's like, I like it, but right, it's quite a big change to the EVM. And now, kind of moving on from the, I guess, the EOF era. So these four, as I mentioned, yeah. So these four, the ones I talked about. So the top two, including code validation, they're very likely to get in. So that's the one where I would like to get the most feedback on. But I really hope that the static jumps are going to get in. Now, the function section, which is the most intrusive, but also really interesting one, because that is the one enabling the complete removal of dynamic jumps. But I think that is probably the most complex and most risky to introduce. So you would be the best audience to give feedback on this EIP. And now moving on to another EIP we have here, which is the authorization feature. Have anybody heard about this before? Not many of you. So this is part of the account abstraction direction, which means to make EOAs and user accounts much more smart. And what this proposal is trying to do is that as an EOA, you can authorize a contract to interact in your name, which means to send calls with your address. And the way this is achieved is by two instructions. We have the first instruction where you pass in an ECDSA signature, and you authorize this contract to act in your name. This is kind of like the permit functionality for ERC20. So this contract would store this signature, and whenever it wants to interact in your name, it's going to call this instruction, which sets a context variable whether the authorization was successful or not. And from that point on, whether it uses this auth call instruction, it's going to make a call with your address. This would enable a lot of different use cases. And this was proposed a year ago at this point. The reason it failed, because, yeah, what is the reason? Do you have any idea? Okay, the reason is it cannot be revoked. Once you give this authorization, it's done. And whatever happens with the contract, if it's hacked, your EOA is like fully compromised. So with EOF, there would be an option to actually make this revocable. We could use these code sections to have a special code section for validation. And this validation means that whenever you use this, this auth call instruction, it would check if the resolved address is a contract, and if it is a contract, then it calls this validate, and if that returns true, then it can be authorized, and if it returns false, then it has been revoked. And now you ask, okay, but it's an EOA we're talking about. How the hell can it have code? So there's like another proposal to make that happen, which I haven't listed because it's too new. There are a few more use cases already for this EOF stuff. There's like another, I wanted to just mention, this address space extension discussion, which might be interesting to you guys. Currently, all the addresses are 20 bytes long. The idea is to make them 32 bytes long. which is simple enough, right? But all the contracts are kind of depending and not depending on it. Depends on the solidity optimizer. Some cases it masks them, truncates them. In other cases it doesn't. So we cannot just do it. We have to have some more complex system in place, and the COF proposal may help with that. There's also like another proposal to have complete control flow validation at deploy time, which would mean it would ensure that there wouldn't be any kind of stack underflow or overflow. Really great idea, a lot to be done at this point. I mean, that was the talk, but I do have a few bonus slides if we have time and we don't have questions. No questions then. Okay, I'm gonna show this. So we have been, with the EOF, the idea was that we could also change other missing features, like do checked arithmetics. If I mention SafeNav, all of you know what I mean. So we were looking into ways to do that, and it turned out we actually don't need EOF for it. But we looked at one specific use case, which is the MolDiv. Actually gonna go here. Did you guys see this before? It's a long code. One person knows. I think every single one of you uses this. Have you ever made a Uniswap transaction? Yeah, this is the code in Uniswap. It's quite long. And we would be able to replace this long piece of code with a single instruction. And the really cool part here is figuring out a way how to have a single instruction which can do both checked and unchecked arithmetics. And I think we found like a way to do it. And this EIP 5000, if we can convince the EIP editors for this number, then it's EIP 5000. And this is like a really cool way. And it may set the precedence how we do checked arithmetics for the other instructions. And I ran out of time, and I guess we have questions?
See if you have questions, otherwise you can add an extra bonus. Any questions for Alex? All right, can I request you to please come and take the... If I can just repeat the question, what are the gas savings on MolDiv for Uniswap?
Yeah, so the opcode itself doesn't do checked arithmetics. It helps you do checked arithmetics, and this like the workaround you have to do checked arithmetics. So this costs roughly 25-30 gas, and the current code is like 250 gas. So this piece is 250-ish. This is 30, and you use this, I don't know entirely how many times, but I would guess like 20 times at least, 10, 20 times, so you scale it up. But Uniswap is used all the time.
Any other questions for Alex? You may have time for a bonus slide.
I actually removed the other bonus slides because there were just too many of them. But anyway, I just really hope to open your mind to all these different proposals which are out there, because what happens is that I don't think really the protocol devs, the actual application devs, and security people, they don't really seem to be, and language designers, like all these 4 categories, they don't seem to be interacting that much. And nobody is like giving input, from these other layers into protocol. In protocol, we just look at, we would like to improve EVM in a certain way. And it makes sense to us. It may not make sense to you. It may not make sense to language designers. So I wanted just to give you like a little overview, what is going on, and hope that you guys start interacting, with the protocol people on this.
All right, fantastic. Thank you, Alex.
Thank you.